So this is going to be the last of the videos for this content. This gets us basically through the vast majority, the important chunk of chapter number 16. So what is a salt? A neutralization reaction, or a reaction between an acid and base, is going to produce a salt and water. A salt is an ionic compound formed from the reaction of an acid with a base. Okay. This is not really new information. We've talked about this before. We talked about this in Gen Chem 1. Now, salt solutions. Well, Mx plus water is going to cause these things to dissociate. Each ion formed has the potential to react with water to produce an acid or base that it came from. Now, when a substance reacts with water, the reaction is called a hydrolysis reaction. If an ion reacts with water, a pH change will occur. Depending on the salt, a solution can either become acidic, basic, or remain neutral. So the question then is which ions will react with water? And the ions that will react with water are ions which came from a weak acid or a weak base. Great examples of those are acetate and ammonium. A weak acid being acetic acid, and a weak base like ammonia are great examples. Now we can go ahead and ignore ions which came from strong acids or bases, and that's because, for example, NaCl. Well, Cl minus and Na, those came from strong acids like HCl and a strong base like sodium hydroxide. Cation in the salt came from a base, and an anion in the salt came from an acid. Now, this table right here really gives you everything that you need to know to answer questions related to this. So, if the salt or the components of the salt came from a strong base and a strong acid, you're going to make a neutral solution. So what that effectively means is if you add a bunch of sodium chloride, Na plus and Cl minus to water, your pH isn't going to change that dramatically. Meanwhile, if your salt came from a strong acid and a weak base, you're going to end up with an acidic solution. If your salt is made up of a component from a strong base and a weak acid, you're more than likely going to end up with a basic salt. Now, here's some good examples. Which of the following compounds will produce a basic solution when dissolved in water? NaNO3, HF, NH4Cl, Na2CO3, and NaCl. Okay, so what we're looking for is whenever we see this, we want to be thinking about, well, where did the Na come from? Where did the NO3 come from? Well, if we think about this, okay, so if we're thinking about a strong acid or a strong base, NaOH is a strong acid. HNO3, well, that's a strong acid. Now, this is a little bit tricky to remember, especially when we're first being exposed to this, but here's that table again. Where did the ions come from? Okay, if we have a salt made up of components from a strong acid and a strong base, as is the case with sodium hydroxide and nitric acid, well then we're dealing with a neutral salt. So the solution that NaNO3 is going to be found in, well, that's going to be neutral. Okay, now next up is HF. Which of these is going to produce a basic solution? HF, hydrofluoric acid. Well, by nature, that's an acidic solution. So we're going to go ahead and take that off the table. NH4Cl. Okay, so ammonium and chloride. Okay, so Cl more than likely coming from HCl. So that's a cation coming from that's an anion coming from a strong acid. And ammonium is going to be coming from a weak base. So here what we have is a weak base plus a strong acid. Now with that combination, weak base, strong acid, that's going to give us an acidic salt. So is that a basic solution? That's not. Okay. Oh, rats. Scribble, scribble, scribble. Now erase this, erase that. Okay. Na2CO3. Okay, CO3, Na2. Okay, so that's more than likely from a strong base like NaOH and H2CO3. H2CO3, carbonic acid. That is not a strong acid. That's a weak acid. So weak base, or yeah, a weak acid, I'm sorry, right here, and a strong base coming together. That's going to give us a basic salt. That's going to give us our basic solution. Okay, our last but not least one is going to be, boop, boop, is going to be NaCl. Na is sodium hydroxide and HCl. That's a strong acid mixed with a strong base. Those are going to cancel one another out. We're dealing with a neutral solution. So D, Na2CO3 is our correct answer. Okay, next up, when NH4Cl is dissolved in water, the solution will be acidic, basic, neutral. Additional information is needed. Okay, so NH4, the way that I always like to think about this is break these components down. I like to say, okay, NH4, OH, ammonium hydroxide mixed with HCl. Okay, here what we have is a strong acid and a weak base. Okay, strong acid plus a weak base, that's going to give us an acidic salt, so that's going to give us an acidic solution, A. So anytime you see a compound, think about what did the two components originate from? Well, ammonium hydroxide. Try to find that cation and throw hydroxide on it. Find the anion and put a hydrogen in front of it. Is it a strong acid? Try to identify what it kind of came from, its predecessor molecule. All right, I hope that was helpful, and if you've got any questions about any of this, let me know. I've worked through the homework. The homework is challenging, but it's all related to all of this stuff. There's definitely some, like, make a turn here, make a turn there, but the foundations are all there. All right, have a good one.